In this video, we'll be looking at what hyperbolic functions are and drawing their graphs. So hyperbolic functions are actually exponential functions that have a lot of similarities with trig functions. So I'm going to begin by defining a couple of them. So the first hyperbolic function I'm going to define is what's called a hyperbolic cosine. So hyperbolic cosine. And that's written with cos in front, as cosine would be, but then it's followed by an h, and that h is what indicates that it's a hyperbolic function. So hyperbolic cosine of x is equal to e to the x plus e to the negative x over 2. So sometimes we like to have a shorthand way of pronouncing this. So this is sometimes pronounced cosh x, or sometimes we say cosh x. So instead of saying hyperbolic cosine every single time, sometimes we'll just say cosh x or cosh x. Alright, so what does this graph look like? So if we were to graph this, so I'll draw my xy plane, and then let's write y equals cosh x, so our hyperbolic cosine function. So before I draw what this graph looks like, let's see if we can write down a couple of properties that'll help us motivate what the graph looks like. So first, I'll plug 0 into hyperbolic cosine. And if we do that, we end up with e to the 0 plus e to the negative 0 over 2. And simplifying this, we get 1 plus 1 on top, so 2 over 2, which is 1. So when we plug 0 into the function, we get 1 out. So that means it goes through the point 0, 1. And then if you plug negative x into hyperbolic cosine, and then evaluate what we get out, so if we plug negative x in, we'll get e to the negative x plus e to the negative x, which is just e to the x, and then over 2. But that's the same thing as just hyperbolic cosine of x. So this ends up just being hyperbolic cosine of x. So if you have a function and we plug negative x into it, and that equals the same thing as just the original function, that makes this what's called an even function. So it's an even function. And graphically, even functions are symmetric about the y-axis. So whatever they look like to one side of the y-axis, the other part of the graph on the other side of the y-axis is going to be the mirror image of that. So it turns out that if we draw up more of this graph, to the right-hand side of the y-axis, it looks like this. It starts to increase. So on the other side of the y-axis, it's going to be the mirror image of that. So it's going to be the mirror image of that. So we have this even function, which means it's symmetric about the y-axis. So these two properties, the fact that when we plug 0 into the function, we got 1 out, and the fact that it's even, makes this similar to just regular old cosine. Cosine has these same two properties. When we plug 0 in, we get 1 out, and it's an even function. It's symmetric about the y-axis, although the graph looks different. Alright, so now let's talk about hyperbolic sine. So hyperbolic sine of x has a really similar definition. It's e to the x minus e to the negative x over 2. And you might be wondering, well, where are these weird sort of looking exponential formulas coming from? And I'll motivate that in the next video. Alright, so this is called hyperbolic sine. Hyperbolic sine. And this is sometimes pronounced cinch. So the way the word cinch is written is we actually write C-I-N-C-H. So this is pronounced cinch. So we have cosh and cinch. Alright, so now let's draw the graph of this. So I'll draw my xy axes. So let's draw the graph of y equals hyperbolic sine of x, or cinch x. Okay, so cinch has two similar properties. When you plug 0 into it, we'll end up getting 0. And when you plug negative x into hyperbolic sine, you get the original function, but with a negative out in front this time. And that makes hyperbolic sine what's called an odd function. And an odd function also has a symmetry, but not about the y-axis. This is symmetric about the origin. So whatever the graph looks like on one side of the origin, it's going to be the mirror image of that on the other side of the origin. And it turns out that to the right of the origin, the graph looks like this. So it's going to be the mirror image of that on the other side of the origin. So if for example, I take a point like this and I draw the mirror image of that on the other side of the origin, the mirror image would be here. And if I keep drawing mirror images, but this time across the origin, my graph will look something like this. So the hyperbolic sine graph looks something like that. Alright. So these two properties are similar to sine, just the regular sine function, not hyperbolic sine. So hyperbolic sine and the regular sine function have these parallels. When you plug 0 into both of them, you get the same value out, you get 0. And they're both odd functions. They're both symmetric about the origin. Next, let's define the other hyperbolic trig functions. Alright, so hyperbolic tangent is going to be, I think, what we'd expect. It's going to be hyperbolic sine divided by hyperbolic cosine. Kind of like tangent is. Tangent is sine over cosine, so the hyperbolic analog of it is going to be the same quotient, but with the hyperbolic analogs. Hyperbolic sine on top, hyperbolic cosine on bottom. Hyperbolic cotangent is the reciprocal of that. So it's hyperbolic cosine of x divided by hyperbolic sine of x. Hyperbolic secant is going to be 1 over cosh x. And cosecant hyperbolic is going to be 1 over sinh of x. Alright, so at this point, if we think back to our learning goals, we have done learning goal 1. We have defined and graphed certain hyperbolic functions. So in the next video, we will look at some identities that hyperbolic functions satisfy, and then start talking about formulas for their derivatives.